Hi, we are back again with another discussion on time and distance. Hope you would recollect the basics on time and distance. In this discussion, we shall build on the concepts we learned there and look at application level questions from time and distance. However, we shall spend a few minutes to quickly go through some of the important concepts we learned about this topic just in case you have forgotten them. We define speed as the rate at which distance is traveled. Speed equals distance by time. Using this relation, if we know the value of any two of the three variables, the value of the third variable can easily be found. If we know distance and time, we can find speed as distance by time. If we know distance and speed, time taken can be found as time equals distance by speed. If we know speed and time, distance can be found as distance equals speed into time. In most of the questions that we encounter from this section, we assume that speed of an object remains constant during the given period. Even though this may not be possible in most of the real life situations, it helps to reduce complexity of the given scenario. Using the fundamental relationships, we make certain observations that will come handy when we try to do aptitude questions under a time constraint. Speed is distance by time. From this relation, we can observe that under conditions where speed is a constant or does not change, distance and time will be directly proportional. For example, if we have a body moving at constant speed, it will travel more distance in more time and less distance in less time. You double the travel time, the distance traveled will also be doubled. From the relation time is distance by speed, we can observe that when time remains constant, distance and speed are directly proportional. To give an illustration, if we have two people walking for the same time, let us say 1 hour, the one with the larger speed will travel a larger distance. If one person walks at double the speed of the other, he will cover double the distance covered by the other. From the distance relation, distance equal to speed into time, we can see that when distance is a constant, speed and time are inversely proportional. For example, let us assume that you walk from your hostel to the college every day. The distance remains the same. If you increase your speed, the time taken comes down, and if you decrease the speed, the time taken goes up. Speed is distance by time. So the unit of speed will be unit of distance by the unit of time. Commonly used units of speed are kilometers per hour and meters per second. While doing questions, you will have to convert from one unit to the other quite frequently. In such occasions, the conversion relation will be very useful. Remember that 1 kilometer per hour is 5 by 18 meter per second, and 1 meter per second is 18 by 5 kilometers per hour. Now let us turn to some questions from this set. Refer to the first question. In this question, as you can see, we have two trains A and B starting at the same time from two distant stations and going in opposite directions. They cross each other at a certain distance from one of the stations, and we are asked to find the ratio of their speeds. An important thing that should be kept in mind while doing this question is that we would assume the trains to be moving at constant speeds. That is, they do not accelerate or decelerate. From the beginning to the end of the journey, they maintain whatever speeds they are having. Their speeds could be different, but they maintain the speeds. When the two trains cross each other, the sum of distances traveled by them till that moment should be equal to the total distance of 375 kilometers. It is given that the two trains cross each other at a distance of 250 kilometers from one of the stations. One of the trains would have traveled this distance, and the distance traveled by the other train should be the remaining distance of 375 minus 250, that is 125 kilometers. Keep in mind that in all the problems involving time and distance, we are playing with three parameters: speed, distance, and time. In this question, if we consider the journey of the trains till the moment they meet, the variable that remains constant or takes the same value for both trains is the time. They started at the same time and traveled for the same time till they met. Distances traveled are different: 250 kilometers for one train and 125 kilometers for the other. Speeds will also be different. We know that when the two bodies are traveling for the same time, the one with the larger speed travels a larger distance. Distance and speed will be directly proportional. Ratio of distances will be equal to ratio of the speeds. Here, the ratio of distances is 250 is to 125 or 2 is to 1. So the ratio of speeds will also be the same, that is 2 is to 1. Now let us look at the next question, question number 2. In this question, we are having two bodies A and B. Three pieces of information are given in the statements. 1. The ratio of speeds of A and B are 4 is to 5. 2. The distance traveled by them are the same. And 3. A takes 10 minutes more than B to reach the destination. Using this, we are asked to find the time taken by B to reach the destination. In problems of this kind, if you could identify the variable that is constant, it would be very easy. It is clearly mentioned in this question that A and B are covering the same distance. So we can equate the distances here. We know that distance is speed into time. So the distance traveled by A equals speed of A into time taken by A. Similarly, distance traveled by B equals speed of B into time taken by B. Since the distance traveled is the same in the case of A and B, we can equate the two. It is given that the ratio of speeds of A and B is 4 is to 5. What does that mean? It means that if the speed of A is 4, then the speed of B is 5. If the speed of A is 8, then the speed of B is 10. If the speed of A is 40, then the speed of B is 50, and so on. If the speed of A is 4 units, then the speed of B is 5 units. Let us take the speed of A as 4k. Then the speed of B will be 5k. So we can rewrite the earlier relation as 4k into time of A equals 5k into time of B. It is known that A takes 10 minutes more than B. So, time of A equals time of B plus 10. Substituting this, we have 4k into time of B plus 10 should be equal to 5k into time of B. And when you solve, you get the value of TB or time of B as 40 minutes or 2 by 3 hours. In answering this question, the approach was directed by the fact that distance is the same, and so we equate the two distances. Now let us move on and look at three important types of application questions. that are commonly asked in aptitude test papers. They are problems on trains, problems on boats and streams, and problems related to races. We shall look at some questions from each of these categories. Time and distance problems on trains come in three forms. The first type is one in which the train crosses a man or a pole or an object whose dimensions are negligible in comparison to the length of the train. In the second type, situations in which a train crosses a bridge, a platform, or a tunnel may be given. And in the third type, we will have situations where two trains cross over. In almost all these questions, you will be given two of the three variables speed, distance, and time, and asked to find the third. While handling these questions, it would be good if we can keep in mind the following. When a train crosses a man or a pole, the distance covered will be equal to the length of the train. When a train crosses a tunnel, a bridge, or a platform, the distance traveled equals length of train plus length of tunnel, bridge, or platform. When two trains cross over, the distance to be traveled is equal to length of the first train plus length of the second train. Now let us look at question Q3. There are two parts to this question. In the first part, a train is crossing a person by the railway track, and in the second part, the train crosses a bridge. We are asked to find the speed of the train and the length of the bridge. We know that speed is distance by time. The train takes 10 seconds to pass the person. What is the distance traveled here? As the width of the person is negligible in comparison to the length of the train, we can say that when the train crosses the person, the distance the train has to travel is length of the train, which is 100 meters in this question. And the train crosses that distance in 10 seconds. So, the speed of the train can be found as distance by time, or 100 meters in 10 seconds, which is 10 meters per second. We need the answer in kilometers per hour, not in meter per second. So we need to convert 10 meter per second to kilometers per hour. 10 meter per second is 10 into 18 by 5, or 36 kilometers per hour. Now let us look at the second part of the question. It is given that the train takes 50 seconds to cross the bridge, and we are asked to find the length of the bridge. You need to understand that when the train crosses the bridge, the distance covered will be length of the train plus length of the bridge. A simple visualization will help you understand this. Let us say that the train has a length L and the bridge has a length B. We will say that the train has started crossing the bridge when the engine of the train is in line with the entry of the bridge. After some time, the engine of the train reaches the other end of the bridge. By now, the train would have traveled the length of the bridge. Did the train cross the bridge? No. The train is still on the bridge. Only the engine has reached the other end. After some time, once the last compartment of the train moves out of the bridge, we can say that the train has crossed the bridge. From the previous position to the current position, the train should have traveled a distance equal to the length of the train. So the total distance the train has to travel while crossing the bridge equals length of the bridge plus length of the train. It is given that the train crosses the bridge in 50 seconds. distance traveled by the train in 50 seconds is given by distance equals speed into time, or 10 meter per second into 50 seconds, which is 500 meters. This distance is the sum of length of the bridge and length of the train. We already know the length of the train as 100 meters. So the length of the bridge should be 500 minus 100, which is 400 meters. In the previous slides, we looked at time and distance problems involving trains. Now let us look at another category of questions in which boats and streams are involved. In a typical problem from this category, we would have a boat traveling in a river. In place of the boat, it could be a swimmer swimming in the stream, a rower rowing in a river, a glider gliding in a windy atmosphere, etc. The approach remains the same in all these cases. Let us assume the still water speed of the boat to be b kilometers per hour, and let the speed of river be w kilometers per hour. Still water speed means the speed of the boat in the lake or a pond which does not have water current. That is, the boat's own speed. When we say the speed of water is w kilometers per hour, what we mean is that if we keep some floating object like a log or wood on the river would carry that w kilometers in an hour. In the problems that we come across from this topic, we encounter two situations. One in which the boat travels in the direction of the flow of the river or stream, which is called the downstream direction. It is called downstream direction because water always flows from a higher level to a lower level, that is downwards. So the direction of natural flow of the stream or river is the downstream direction. When the boat travels in downstream direction, the flow of water supports the normal speed of the boat. So the net downward speed or downstream speed will be equal to speed of the boat in still water plus speed of the river, that is b plus w. The other situation is one in which the boat travels in the opposite direction to the flow of the river. This direction is called upstream direction. When the boat travels in the upstream direction, the flow of water opposes the boat, and so the speed gets reduced. Thus, the effective upstream speed is given by speed of the boat in still water minus speed of the river, which is b minus w. Take a look at question Q5 given in the slide. In the situation given, the boat travels 24 kilometers downstream in 2 hours and 20 kilometers upstream in 2 hours. And from this information, we are asked to find the speed of the river. From our earlier discussion, we know that in downstream movement, the river and the boat are trying to move in the same direction. As the river is aiding the movement of the boat, the effective downstream speed is given by speed of the boat plus speed of the river. So the downstream speed is b plus w. In the upstream direction, the movement of the boat is opposed by the river. So the upstream speed is b minus w. In the question, it is given that the boat travels 24 kilometers downstream in 2 hours. So the speed of the boat in downstream direction is distance by time, which is 24 by 2 or 12 kilometers per hour. The boat travels 20 kilometers upstream in 2 hours. So the speed of the boat in upstream direction will be distance by time again, which is 20 kilometers by 2 hours or 10 kilometers per hour. So we can write B plus W equals 12 and B minus W is 10. Subtracting the second equation from the first, we have 2W equals 2 or W equals 1. That means the speed of the river is 1 kilometer per hour. From the same set of equations, we would also get the speed of the boat as B equals 11 kilometers per hour. Next, let us look at a couple of questions from races, which in turn is an application of time and distance. In an 800-meter race, A beats B by 80 meters or 10 seconds. What is the speed of A? In order to do this problem and similar problems from this category, we should assume that A and B run at constant speeds. Even though, from a practical point of view, that is not feasible, we would have to assume such a thing to do this question. Even though there is just one sentence in the question, there is a lot to understand here. It says that the race was an 800-meter race. A beats B means A won the race. That is, A finished the race first. A beats B by 80 meters means when A reached the finishing point, B was 80 meters behind. A beats B by 10 seconds means B took 10 seconds more to finish the race after completion by A. Even though it is not explicitly stated here, we would assume that A and B started the race together. That is a standard approach in any race-related question. If a person starts earlier than the other, then it would be mentioned specially as a lead of that person. Take a look at the illustration given in the slide. As mentioned earlier, we should assume that A and B run at constant speeds. Understand that constant speed does not mean A and B have the same speed. If that was the case, they would have reached the finishing point at the same time. A has a higher speed than B. That is why A won the race. Constant speed just means that whatever was the speed of A maintains that speed throughout the race. And whatever was the speed of B maintains that speed from the beginning to the end. A and B began the race together. When A reached the finishing point, B was 80 meters behind. And B took another 10 seconds to cover this 80 meters. That means B ran 80 meters in 10 seconds. So we can find the speed of B as 80 meters by 10 seconds, or it is 8 meter per second. One thing we can say now about the speed of A is that the speed of A would be more than 8 meter per second. How can you find the exact value? Look at the illustration once again. We can see that in the time in which A runs the full distance of 800 meters, B runs only 720 meters. That is 800 minus 80. Time taken by B to run the 720 meters can be found out easily. It is given by time equals distance by speed, or 720 meters by 8 meter per second, which will be 90 seconds. In these 90 seconds, A will run the full distance of 800 meters. So the speed of A equals distance by time, or 800 by 90, or 8.88 meter per second. Let us look at one more question from this section. The question describes a circular track in which two cyclists are cycling. They start from the same point at the same time and are cycling in the same direction. We are asked to find the time after their start at which the two will meet for the first time at the starting point. It is given that the professional cyclist completes a lap in 3 minutes. So after 3 minutes, he will be at the starting point for the first time. But as the novice takes 4 minutes to complete a lap, he will be behind and will reach the starting point only after 1 more minute. By that time, the professional would have moved ahead. If you observe the situation closely, you can see that the professional cyclist reaches the starting point at times 3, 6, 9, 12, 15, etc. minutes after the start. The novice reaches the starting point after 4, 8, 12, 16, 20, etc. minutes after the start. We can see that both the professional and the novice are together for the first time at the starting point at time 12 minutes after the start. This 12 is the least common multiple of 3 and 4. You should note that this is the time at which they meet for the first time at the starting point. They could have met at some other place in the track other than the starting point before this. And the second time they meet at the starting point would be at 24th minute. As we end this presentation, it would be good to take a quick recap of the various aspects of time and distance that we discussed here. To begin with, we refreshed the basics of time and distance. We went through the various relationships between speed, distance, and time. Units of speed and the conversion from one to other were looked at. After solving some simple problems, we moved to application questions based on trains, boats and streams, and races.